Hi students, how are you? Today we will discuss kinematics 1D motion, and particularly I will cover the topics about acceleration due to gravity, and freely falling bodies. We will write equations of motion under free fall. If a body projected vertically upwards, what are the equations? And we will do some numericals also. This class is very important for the foundation students who are in 6th standard, 7th standard, 8th standard, and also it is very important for IPE students, intermediate first year, who are going to write competitive examinations. So we will start. I will start with acceleration. Acceleration can be defined as rate of change of velocity. Rate of change of means change in velocity with respect to time. That's it. So from the definition we can write acceleration a bar is equal to velocity by time. Actually rate of change in velocity, you have to write delta v by delta t, change in time. Suppose time intervals initial 0, after some time interval t2 is t, we can write final velocity minus initial velocity, change in velocity format, final velocity minus initial velocity. Suppose initial velocity taken as 0, initial time taken as 0, then we can able to write velocity by time simply. Acceleration a bar is equal to velocity by time. How acceleration will be understand? If you observe, there is a car is moving with a velocity initial. A car is moving with velocity, initial velocity u. After some time, a car reaches here. Now the car is moving with velocity v, and here my assumption is final velocity is greater than initial velocity. This is greater than this velocity. Means accelerated, the car changes its velocity, means suppose u taken as 3 km per hour and v taken as 6 km per hour, then what happen? Velocity going to be increases. In this situation we will call this as acceleration. This is nothing but acceleration. Suppose this is situation 1 or case 1. In case 2, a car is moving. You have to write geographic directions: east, west, north, south. A car is moving along east initially with 3 kilometer per hour, and suddenly changes its direction towards north. A car initially moving towards east. If you observe east direction, and suddenly changes its direction towards north. Now the car is moving towards north, but the speed remains same, 3 km per hour only. Magnitude remains same, 3 km per hour, 3 km per hour. But here direction changes. In this situation also we will call this is as acceleration. Means either magnitude changes gives rise acceleration, or direction changes gives rise acceleration. That's it. That is acceleration. And coming to average acceleration. Average acceleration defined as change in velocity in unit time is called average acceleration. Acceleration avg is equal to v2 minus v1, final velocity minus initial velocity by unit time, is nothing but average acceleration. Now what are the SI units for the acceleration? Is the acceleration vector. S bar indicates that vector. Acceleration is a vector quantity. I hope all of you understood what is acceleration. Rate of change of velocity is acceleration. Now, it is a vector. It is a vector. If I write SI units, acceleration A bar is equal to V bar by T. SI unit for velocity already we have done it in the previous class, meter per second by time T another S. So finally meter per second square we will get, or meter S power minus 2 SI units for acceleration. If I write dimensional formula, MLT is the identification for dimensional formula. M mass, there is no mass in the format, so M naught. L indicates that length, meter, so power 1 is there. L1. T time, power minus 2, T power minus 2. Second indicates that T power minus 2. This is the dimensional formula. Now we will discuss whenever the object is said to be accelerated motion and whenever it is said to be decelerated motion. Accelerated motion or acceleration. Accelerated motion. Suppose there is a car. The car is moving. Initial speed of car, velocity v1. Initial speed v1 5 kilometer per hour. After some time, the car reaches here and again it is moving with a speed 10 kilometer per hour. After some time, the car reaches here. This is V2, that is V3 given 17 kilometer per hour. After some time, the car reaches here. Now V4, that is moving with 20 kilometer per 25 kilometer per hour. What we can observe here? Here the car remains moving with increasing velocity. Velocity V1 5, 10, 17, 25, like this. The velocity is going to be increases. So this situation is considered to be accelerated motion. Let us imagine this is happen regular intervals of time. Regular intervals of time. Then this kind of motion is known as accelerated motion. A very simple example we can imagine. Suppose we are moving in the highway. Suddenly a red signal came. What you will do? You are in the car. You will apply brakes. You will stop at the red signal. Right now your speed is 0. A green signal came. What you will do? You will start your car. You will move. 0 kilometer per hour, 5 kilometer per hour, 10 kilometer per hour. This is nothing but accelerated motion. You will give acceleration. Finally, you can able to touch 80 kilometer per hour. This is accelerated motion. And what is decelerated motion? Decelerated motion is nothing but opposite for this. To understand decelerated motion, initially your car is moving with 80 kilometer per hour. So decelerated motion. Decelerated motion. Your car is moving initially 80 kilometer per hour. 80 kilometer per hour. Now there is a red signal. You will observe that red signal. You are on the highway. So what you will do? You will apply brakes. As a result, the car speed will going down as 60 kilometer per hour. And next instant, the speed of the car will be 50 kilometer per hour, and the next instant the speed of the car will be, it may be 30 kilometer per hour. In this way, the gradually increases the speed, the finally speed become velocity final become 0 kilometer per hour at the signal point. You will stop your car. What happened here? The speed is regular intervals of time, speed is going to be decreases. As a result, we are getting decelerated motion. We can observe at a highway, you observe the red signal, you will apply brakes, your car speed will be going to be decreases, is nothing but decelerated motion, or you can call this as retardation. Okay, now we will understand some examples on the basis of acceleration. Suppose a car is moving towards the east with a speed 80 kilometer per hour. 80 kilometer per hour. Suddenly, its speed going to be decreases. Speed is going to be decreases. Means this is V1 for example, V2 60 kilometer per hour, V3 40 kilometer per hour. Like this, speed is going to be decreases, but the direction of motion of the car remains towards east only, but it is taking deceleration. Yes or no? It is taking deceleration, means this way. A bar, decelerated motion, nothing but retardation, denote by letter A bar, but you have to put negative sign. Why? Because if you observe rate of change of velocity here, acceleration, change in velocity by change in time, V2 minus V1 by t. What is V2? 60 minus 80 by, suppose it is happen in a time interval of 2 seconds, 80 to 60 kilometer per hour. 2, what you will get? You will get minus 20 by 2 minus 10 meter per second square, sorry, kilometer per hour square. Means negative sign indicates that car is going to be decelerated. The motion of the car is decelerated motion. Now if you observe, still the car is moving towards the east, but it is taking deceleration, A bar. So what is the angle between velocity vector V bar, since car is moving this way, velocity vector V bar, and accelerated vector, velocity vector V bar, acceleration vector A bar? We can say 180 degrees is the answer. The angle between velocity vector and accelerated vector is 180 degrees. This kind of scenario we can observe in case of decelerated motion. Yes or no? Now we are going to discuss about acceleration due to gravity. Acceleration due to gravity, denote by letter G. Acceleration due to gravity denote by letter G. If any object thrown vertically upward, suppose if I throw vertically upward or any other direction, if I throw any object, on this object the only force acting is acceleration due to gravity. If I throw any object, suppose this is a earth surface, finally the object coming towards the center of the earth only. Yes or no? Suppose if I throw any object this way, finally due to gravity the object coming towards the center of the earth, suppose this is center of the earth. If I throw any object this way, finally it is coming towards the center of the earth, it is taking this part and coming towards the center of the earth. What happened here? Because of gravity the bodies are coming towards the center of the earth. Here the only force acting on the objects are G, acceleration due to gravity. Yes or no? The effective force only acting on the objects are G, acceleration due to gravity. So we can define acceleration due to gravity as any object on the earth is pulled towards the center of earth. When it will happen? If no other force acts, then the body moving with acceleration, due to gravity is called acceleration due to gravity. Any object on the earth is pulled towards the center of the earth. If no other force acts, then the motion of the body is known as acceleration due to gravity, denoted by letter G. So acceleration due to gravity, A is equal to G actually. So if I write SI units, what are the SI units for acceleration A? Those SI units, meter per second square only, and dimensional formula also remains same as acceleration due to gravity. And the magnitude of acceleration due to gravity G is 9.8 meter per second square. This is G value, small g value. Okay. And G does not depends on size and shape of the objects. It does not depends on whatever the size it is. Suppose if you observe, this is a small size. If I throw this, it is coming downward again. Understand? Suppose this is a big size. If I throw this, it is coming downward again. So G does not depends on shape and size of the object. What is the shape? Whatever the size, it remains same. Its value is 9.8 meter per second square, equal in any size of objects. And it is independent of direction. Means G does not depends on particular direction. Whatever the bodies are moving, if the bodies are moving particular direction, upward, downward, okay, horizontally, moving forward direction, G always acts towards the center only. So G is acting, means G pulls the bodies towards the center only. Understand? Means G always acts vertically downward. It is independent of direction of objects. Does not depends on direction of object. Whatever the direction of objects, G value remains same on the objects. Understand? This is about acceleration due to gravity. Now, on the basis of acceleration due to gravity, there are sign conventions. You should know sign conventions. What are the sign conventions? To write kinematic equations or motion, 1D motion equations, you have to follow sign conventions. Sign convention. If a body moving towards the earth, towards center of the earth, then you have to take plus G. Then G value is taken as positive or plus G, positive. If a body moving away from the earth, then G value taken as negative. If a body moving, suppose this is the earth surface E, the bodies are moving towards the earth, acceleration due to gravity taken as plus g. If a body is moving away from the earth surface upward, then A is equal to minus g. You have to consider. That's it. This is the sign convention. Okay, on the basis of this, we will discuss vertically projected bodies. After that, we will do numericals. Vertically projected bodies.